Today's experiment is a low pass and high pass filter. A filter is a circuit that passes certain frequencies and attenuates or rejects all other frequencies. The pass band of a filter is the range of frequencies that are allowed to pass through the filter with minimum attenuation. The critical frequency Fc, also called as cutoff frequency, defines the end of the pass band and is normally defined as the point at which the response drops to -3 dB from the pass band response. A low pass filter passes all the frequencies from DC to a particular frequency, critical frequency Fc, and significantly attenuates all other frequencies. In today's experiment, we will be using only passive filters, which uses components like resistance and capacitance only. There are also active filters which make use of these op-amps. Okay, now you can see some of the characteristics of filters like low pass filter, a high pass filter, a band pass filter, and a band stop filter, etc. Okay, there is also a notch filter which stops a particular band of frequencies. Okay, and see, a band pass filter is just the opposite of a notch filter. Okay, now an ideal low pass filter should look like this. It should sharply cut at this particular frequency Fc, but ideally it never happens. It gradually rolls off to another frequency. Now in today's class we will see the frequency response curves of a low pass filter and a high pass filter also. So these are the components needed for the experiment: a 10K resistor and a 0.01 microfarad capacitor. And the equipments that we need are a function generator, an oscilloscope, a breadboard. Okay. Now see, we have connected the resistor and capacitor also. To one end of the resistor we have given the function generator, and the other end of the resistor we have connected a capacitor, and the other end of the capacitor is again grounded. Okay, so now we have connected the circuit. Now we will be giving a input signal of 50 Hz and 10 volts peak to peak. Okay, and we will see the output response in an oscilloscope. See, this is the output voltage of the circuit which I am seeing in an oscilloscope. The output indicates that it is of 10.1 volts. Okay, so I have given an input of 10 volts as signal, and at the output I am getting 10 volts. Okay, so now what I will do, I will go on increasing gradually the frequency of from the function generator. Okay, and I will note down the amplitude of the output. Okay. Now I will increase the input frequency to 100 Hz. Okay, I am getting same 10.1 volts I am getting. Okay, now I will increase the input frequency to 500 Hz. Okay, see, now the output amplitude has reduced. It has come down to 9.46 volts. Okay, now I will increase the input frequency to 1 kHz. Okay, the output has come to 7.6 volts. Okay, now I will increase it to 2 kHz. the output has come down to 5.2 volts. Okay. Now I will increase it to 3 kilohertz. Now the output is 4 volts. Now I will increase it to 4 kilohertz. Output has come down to 3.12 volts. Five kilohertz. It has come down to around. We can see it has come down to 2.56 volts. Now I will increase the input frequency to 6 kilohertz. Okay. And output is now 2.16 volts. At 7 kilohertz, the output has reduced to 1.92 volts. At 8 kilohertz, the output has become 1.76 volts. At 9 kilohertz, the output is now 1.60 volts. Okay. Now I will be increasing it to 10 kilohertz. At 10 kilohertz, the output has come down to 1.44 volts. Okay, so you can see that as I go on gradually increasing my frequencies, the output has become attenuated. So it is a low pass filter. It will pass the frequencies of low frequency signals only, and high frequency signals it will reject or it will attenuate. Okay, now we shall move for the high pass filter. Okay, now we will start the high pass filter circuit experiment. See, in this case what happens, the resistance and capacitance values are now just interchanged and the output is now taken across the resistor. Now this output has been given to an DSO and now we will see the output in a DSO. Now I have again applied a 10 volt peak to peak 50 Hz signal. Okay, and the output I am getting 480 millivolts. Okay, you can just note down it. Now I will increase it. Now I will increase the input frequency to 100 Hz. Okay, and output I am getting 960 millivolts. Now I will increase the input to 500 Hz. Okay, now output has become 3.84 volts. Now I will increase the input frequency to 1 kilohertz. Okay, the output has become 6.24 volts. Now I will increase the frequency to 2 kilohertz. Okay, now output has become 8.16 volts. Now I will increase the frequency to 2 kilohertz. Okay, the output has become 8.16 volts. At 3 kilohertz of the frequency, output is 9.28 volts. At 4 kilohertz, I am getting an output of 9.2 volts. At 5 kilohertz, I am getting a voltage of 9.76 volts. At 6 kilohertz, okay, I am getting 9.92 volts. At 7 kilohertz, I am getting again 9.92 volts. At 8 kilohertz, I am getting 10 volts. At 9 kilohertz, I am getting 10 volts. At 10 kilohertz, I am getting 10 volts. Okay, so you can very easily see that what happening is, in a high pass filter, whenever these low frequencies were there, my amplitude was getting attenuated, and at high frequencies my amplitude was remaining constant. Okay, this is how a high pass filter works. Now if you plot these frequencies in a semi-logarithmic graph paper, you will get a graph like this. Okay, a semi-logarithmic graph paper, see the x-axis varies logarithmically and the y-axis varies linearly. Okay, in this graph paper you will plot the gain in x-axis and the frequency in x-axis and the gain in y-axis. Okay, see, you will get a graph like this. From the maximum of the point, you come down 3 decibels. You come down, and from there, with the help of a scale, you just draw a straight line. You will see that this straight line will intersect this curve at a particular point. Okay, this particular point is called the critical frequency or the cutoff frequency or the 3 dB frequency. From this particular point, you just draw a straight line downwards. This particular frequency is called the cutoff frequency. Okay, and from the lowest frequency to this frequency, this is called the bandwidth. This is my bandwidth, and this is the 3 dB frequency. Okay, ideally you may expect that a sharp cutoff should be there, but in reality it never happens. It gradually it rolls out. Okay, so in this way you plot a graph for the high pass filter also. So you will find out the cutoff frequency from the graph, and also you calculate you can also calculate it, like FC is given by 1 by twice by RC. From it also you can calculate the cutoff frequency. Okay, so this is the bandwidth. So in today's class you have learnt about the low pass filter frequency response, high pass filter frequency response. You have also known something about pass band, stop band, those things also you know now. Okay, just try to find out why we are giving so much importance to the 3 dB frequencies. That is a task for you. Okay, that's all for today's class.